Greetings, everyone. I hope week one treated you well. This is week number two, lecture number two. I can't believe how fast these 8 week courses go. So when we conclude this week, we'll be a quarter of the way through this course. That is just crazy, but we'll move on. I've got some great information this week. On just general background, a refresher on software and databases. And then we get to talk about Langer, which I will emphasize that the Langer text is critical. If you haven't rented it or purchased it, um, uh, you need to do so. You cannot get through this course without reading Langer and probably reading it 5 times. I had to read very carefully today, but he brought up a lot of things that I've seen in my lengthy career, 30, 32 years now. I've been in information technology and had another 22, 23 years of life before that. So anyway, we'll get going on week two lecture um, for the spring by term. Okay, first up is bourgeois. A couple chapters of bourgeois. Again, this is background introductory material from what would be kind of a refresher from an undergraduate information systems course. If you are unfamiliar with any of these terms, please feel free to email me. Of course, after doing your own independent research. But if you need examples or something's not clear, please contact me. I got one email this week in the first week, one to let me know that about the in putting slides in your documents, and that the instructions for the assignment were unclear. So I don't see any posts in the questions thread, or at least I didn't last time I was in there yesterday morning. Um, so yeah, hit me up, email me if it's something you don't want public. But if you have a question, chances are everyone has the question. And I try to go into that questions thread in week one, the general course questions, and check it every day. Again, don't use course messages to me. Don't message me individually using iLearn. Use email. But if you have a question that you think the group could use, please um, be sure and post that question in the week one general course questions uh, discussion thread, discussion board. Okay, so software this week, something near and dear to all of our hearts. Here's the chapter objectives, kind of focused. There's just a general, uh, these are very specific to what was a fairly general overview chapter. But anyway, that's out of the book, straight out of the book. Two categories of software. They break it down into operating system and application software. I tend to think of it more as systems software, which operating systems are a part of systems software and application software. Um, but they do go into a little bit more detail than that. And as we know, an operating system is what turns that hunk of metal and silicone and plastic into an operating uh, usable device. I'm currently presenting this to you from the operating system Windows 10, but on my desk is also a Raspberry Pi computer with a distribution of Linux on it called Raspbian. If you're not familiar with either Linux or Raspbian, that's a good Google search away. But a Raspberry Pi computer is just a little tiny, inexpensive computer that that you can use to learn Linux or use it for, video gaming, or a lot of people use it for automated controlling, like home alarm systems and stuff like that. Just a cheap little computer. They're pretty cool. Super easy to work with, but fully functional. I could, in theory, use the open office uh, distribution that's on there, and Zoom, um, and do one of these lectures from a little Linux computer the size of a deck of cards. I need to do that. I'll try and do that before we adjourn, just so you see the dual functionality. And an operating system is responsible for all the things that gets the computer ready, but doesn't really do anything. It doesn't apply the computer. That's where the term application software is. It lets you apply the computer to a problem. An operating system lets it operate, manages the file system, it manages memory, the user interface, the print services, the internet, the IP protocol stack, drivers, device drivers, all of that stuff is tied up in the operating system. But you guys know all this, so if you have any questions, you'll let me know. Again, application software. This is They want you to know a particular type of application software, and that's productivity software. But an application can be anything. Can be video editing, or um, productivity software, like I'm using PowerPoint to show you these slides. It could be an application. I think a web browser is a awesomely powerful application in and of itself. And with a web browser, you often don't need application software other than the browser. Like Google Docs and Google Sheets have replaced a lot of applications. So here's productivity software that you're all familiar with. I'm a big fan of Microsoft Office, but I've also used Open Office. Like I said, I got that on my. I was using it on this computer that I use, my main home office desktop. But I went ahead, since I've got a Microsoft Office 365 subscription, I went ahead and downloaded the Office 365 current versions of everything I know and love, and I uninstalled. Oh goodness, I can't even remember the name of it anymore. It's the Open Office Livio. Anyway, I got rid of that open source Office software, and on my Windows 10 machine, but I still have it on my Raspberry Pi. But I use Google productivity at work at the University of Central Arkansas. We use Google Drive, and then of course it's pretty seamlessly integrated with Google Docs and Google Slides and Google Sheets, so that you can do all the normal things that you do. And Gmail, those all. Don't forget your email client is an application, particularly in the productivity world. Access database is also good, but there's Apache OpenOffice has a good database. So this productivity software is just, uh, especially that you'll see the term productivity suite, SUITE, and a suite is just it's a room, it's a set of rooms in a hotel, but it's also a set of applications that work together. So that term has been used more generically. Yeah, application suite, productivity software suite. Um, so you all know and love them. You use them all the time in these assignments. Let me know if you have any questions on that. But then a productivity suite is kind of something that you use perhaps as a member of a team, but maybe as an individual. Um, but the larger organizations you all work in start to use enterprise. Enterprise is just another term for a large organization and its tools and technology and policy and procedures and governance and all of those things, um, all wrapped in together. That's the enterprise. So when you have enterprise resource planning software, it's everything that happens in a business. It's human resources where you bring people on board. It's operations software that controls the flow of manufacturing. It's supply chain management and customer resource management software, as highlighted specifically in Bourgeois Chapter 3. But it when you integrate these things into something where you don't have to, you know, move data via, you know, export data into a spreadsheet and upload it over here and have to move the data around. The more integrated these different functional area support systems become, the closer you get to an ERP suite, an ERP solution. And some software companies will tell you it's a fully tightly integrated ERP solution, but you can tell when a company has bought out a solution and has not fully integrated it into their work. I'm sure some of you have seen that. I use Salesforce to track students at the Arkansas Coding Academy, and we use a plugin. It's owned by Salesforce, but it's not very tightly integrated. It is integrated, but not really. Called Linvio. Linvio and Salesforce, they work together, but it's not as tight as you would think. So that's what you look for when you're evaluating enterprise resource planning software. In my opinion, is how seamless the integration is, and how much it truly looks like one happy family of software working together. But moving ERP, as I say in the second bullet here, moving ERP into an enterprise can be tough. If you go out on Google Scholar, you'll find just a lot of articles on failed ERP implementations, because it is so difficult. So anyway, that's ERP. It tries to do everything that a company needs, all integrated with no gaps in capability or gaps in data flow. There's lots of information out there on the internet if you want to know more. Okay, and then of course, we move into mobile apps, cloud computing. Once you have a backend functioning, backend database, backend business rules in C# or Java or PHP or Ruby on Rails, whatever it is. Once you have the data side of your application working, say say you had a web page and a web application. If you Once you get it working on the back end, you should, if it's developed appropriately, be able to write a mobile app that accesses that same back end fairly seamlessly, so that for the user, the mobile experience and the web experience are very similar. And anything you do on your phone is instantly available on your browser. My favorite um, banking software is one. As soon as you commit that deposit, bam, it's in the system. The first mobile and web application I started using that did that sort of synchronization was years ago. Was called MyFitnessPal, where you track the calories you eat and the exercise you do. And I've been using that for, I don't know, way back 6, 7, 8 years. It seems like a long time. And I thought that's the first time I saw um, a generic application saving something that wasn't no like I say, a banking application. And those mobile banking applications are new. I mean, they didn't. Heck, the iPhone didn't even come out till 2007. What, 13 years ago? So it took a couple years for iPhone and Android to be trusted enough to have banking software on them, and widely used enough. So yeah, I want to say 2010 or 11 was the first time I was able to download a banking app. So it really hadn't been that long. Anyway, anyway, I love talking about information technology, guys. I've been in this business, like I say, 32 years. 1988 is when I got into computers. So if you have questions, man, hit me up. I'm here for you guys. Okay. Anyway, so we got mobile apps. Needs to work on both your smartphone and your tablets. And then if you're in mobile application development in any frame, you got iOS and Android battling it out as platforms. Maybe someday we'll get integrated. But for now, you have to deal with those two separate operating systems and environments. Um, now, uh, the cloud. I'm going to go into cloud computing a little bit more because it mentions it so briefly. But as I say in the second bullet here, it refers to the applications like Salesforce is in the cloud, a software as a service. You just log in and start using it. You don't have to download anything to your computer. So it's applications, it's services like you could hire another company. It could be manual services like accounting and finance, or it could be services like domain name service, uh, DNS entry, DNS server in the cloud, and data storage, especially. Everybody's familiar with cloud storage of your images from your iPhone up in the cloud. I have students. I teach an undergraduate class regularly in introductory information systems. And every time I hear somebody say, gosh, I thought the cloud was owned by Apple and it was used to store your pictures from your iPhone. And they think that's the cloud and cloud computing. And it's, but you guys are master's degree students and you know better than that. So the text goes into the advantages and disadvantages. You lose control, you lose some level of security, you become dependent on the network, but the advantages are huge in reduced cost of maintaining your own infrastructure and flexibility. The ability most cloud-based solutions have both web and mobile um, applications, so you can get to your data from basically from anywhere on any device, and it's all synced up. So make sure you understand a private cloud um, and virtualization. If you're a system administrator, you know all about virtualization, but a private cloud is just using cloud computing, putting resources outside of an organization's network control center, outside of the firewall, and making it available to multiple sources. Now, if you're a big company, if you're Walmart, you could institute a private cloud where all the stores and business units and everything could be absorbing that sort of those resources. Um, and as an entity within your business needed more resources, you could allocate more computing power, more storage. So there's a private cloud. It's kind of like Amazon, but you do it only, you become the Amazon Web Services or Microsoft Azure for your company. But virtualization, you guys need to kind of understand basically what that is. Some of you are experts in it. You're already doing it for a living. Um, but you need to understand virtual means not real. It's an antonym. It's the opposite of actual. So an actual server is a physical computer that you can tap on, and has lights and a hard drive or two or three or five. An actual physical server, actual and physical being synonyms. But a virtual server, there's software out there, techniques where you can create many servers on a single server, and they appear to be, for all intents and purposes, they appear to be a separate physical server to the user. Because a lot of servers, what brought this up was a couple of things. There are several drivers. One was, virtual desktops. That was my first experience with virtualization, was using what was basically a little tiny communications device to let my monitor, keyboard, and mouse uh, communicate with a terminal services server, um, which made your desktop look like you were running a computer, but it was really a virtual PC running on a Windows server, and that Windows server was running terminal services. So that's the first time I got involved in, and goodness, that was 20 years ago, um, in virtualization. But then very soon after that, you started seeing other forms of servers, because a lot of times a physical server would be sitting there not really working very hard. So you could use virtualization to make it be, like three or four or eight virtual servers, and then those virtual servers would actually be busy enough to keep the physical server occupied at a satisfactory rate where you weren't blowing money on hardware. So that's where the economic value of virtualization came around. And then, of course, with distributed computing and the advances in server technology and being able to link um, servers together in parallel computing, it got to be where you could have, you know 32 virtual servers on one physical server, or you can link together 32 physical servers into one whopping mega uh, uh, mainframe supercomputer, and anything in between. That's why you'll see terms like elasticity and scalability. That just means a good cloud architecture will allow the provider, whoever owns the cloud architecture, will allow them to to really give you as little or as much capability as you need in terms of computing power and disk space. Really, are the main resources we're talking about, but others. So that's, and I want to go back into the cloud here. Yeah, I've been using this diagram. Um, oh golly, at least 10 years. It's 2020 already. My goodness. Yeah, I've been using this diagram at least 10 years, probably more, a little bit more. As soon as the term the cloud came out, look for an announcement from me also, or I mean, look for a separate um, piece of information. It'll be a page in the week 2 folder, that talks about the origin of cloud computing. You see that? You see that cloud symbol in the middle that talks that is the internet? Okay, so there's four little sub networks plugged into that represent a router from a small business, and that router could, I mean, it could be an enterprise class router with 2,000 users behind it, or it could be a small home router. It could be a, a router sitting in a little business with 3 or 4 people working at it, a little business location. So each one of these little 4 sub networks sends network traffic out, right? And those TCP/IP packets go into the internet. And these office locations are located around the country, across the world, right? And when that router plugs into the internet, not a dedicated, no kidding, dedicated point to point network, but when it plugs into the internet, it goes across uh, the network traffic traverses any number of routes, and you don't You don't know, and you don't have to care how the network traffic moves from router to router to router, hopping across the internet. It pops out the other side, uh, and you don't as a an IT professional, you don't have to care how the internet made that happen. See what I'm saying? So that's why since you don't know the route that traffic's going to take, and you don't have to care, as I got a telecommunications degree in 2000. We were using this cloud symbol to represent the internet uh, back then, 20 years ago, long before I first heard the term store your data in the cloud. You don't have to worry about a thing because the cloud handles it. So I, I posted a link to that one of that first cloud commercial. It was way back, like 2007 or so, when they first started using this fluffy, uh, lovely, fluffy, friendly symbol for the cloud, meaning the internet. And we had been talking about software as a service and those sorts of things in virtualization in IT, but to make these services and these techniques um, meaningful to the public in a simple way. Uh, they created the advertising agency that was supporting the industry. Microsoft's the first one I saw. A little research might show that there was some other use um, right around the same time, but they came up with this fluffy friendly symbol of the cloud. It's just up there. It's not on your device. That was the main thing they wanted to get across. Don't store your data on your phone. Don't store your data on your PC, because if you drop it off the bridge and into a lake, it's gone, right? Once you lose that device, you lose your data, you lose your applications, you lose your settings. So that was the move to store everything in the cloud. So that's what I remember as being the origin of the cloud. So between this diagram, this discussion I'm giving you, the you'll see a post about the origins and evolution of the term the cloud and cloud computing. Um, uh, Give me a shout or post a question in the general course. So, okay, so and then of course we got creating software. Software are the instructions that make the computer do what you want it to do. And then we've got all these computer programming languages. There's a new one comes along all the time. Python's not new, but it's making a huge resurgence. C is kind of old, but it's still very important out there. That's probably the language you will use if you're doing, no kidding, real time systems or rocket science, computer science programming. C++, of course, incorporated object oriented technologies into C, going back oh, to the 80s. Java was an evolution of C++, to support uh, the growing uh, different ways of doing business on the web and connecting databases to web pages. Visual Basic has kind of gone away. That was back in the Windows 3.0 era, Windows 95. Visual Basic was a nice, clean, simple way to make a Windows-based graphical user interface application. I taught myself some Visual Basic back when I was a programmer. It was pretty good. Again, Python is taking over the data analysis world. R is made perhaps a little more popular among data scientists and statisticians, but R is losing the race to Python for just general purpose data wrangling, data analysis, and back end operations. But then we also want to make sure you understand open source and what you get. Uh, um, you're not allowed to charge people for open source software. The if you modify it and distribute it, you sign an agreement to post. And this environment is taking off. Open source is the future of software. If you're new to software, I would encourage you to jump on that train and ride it, because I mean even Microsoft.net is going open, which was kind of the antithesis of open source software development. But Linux, Unix, Android, the Chrome operating system, Open Office. There's open standard is the way to go. And then and then you got Apple. I personally am not an Apple guy. Apple has always been closed. They're the opposite of open source. They've got, they won't use the standard USB dongle to charge the phone. You got to buy an Apple connector. They wouldn't use whatever, USB. They got to have FireWire. I don't know. Uh, they wouldn't open their architecture like IBM did, um, so that you could have a separation like Microsoft. Microsoft opened up to application development, I think, a little better than Apple did. There's certainly more applications available under Windows than there are Mac OS. So anyway, that's just my opinion. If you're a Mac lover, I understand. Their user interface is great. My brother, may he rest in peace, was a huge Apple aficionado. He was a graphic artist. If you're in video production or graphic arts or any sort of creative side of computing, you're probably a Mac fan, and you hate people like me. And I don't blame you. But it's all in good fun. The whole Mac versus Microsoft, and now I guess there's a third arm out there with Mac versus Microsoft versus totally open source. There are some people that will not pay either one of those companies for their operating systems because there's perfectly good software out there for free. And power to the people. So anyway, make sure you understand the basics of all those types of software: utility software, operating system software, application software, programming languages, what they're focusing on, the difference between proprietary and open source software, where you pay for it or it's just a big open collaborative effort for everybody. So that was the chapter 3. Now chapter 4 uh, of Bourgeois is near and dear to my heart. I know some of you are currently working database experts, and I wish that I had not made the leap into management sometimes. And I wish I'd stayed a database developer because I loved it so much. So you guys at some point, you're in a master's degree program. So yes, you are learning coursework, and you're getting smarter, more detailed information about different technical topics, but you are also moving forward in the way you see information technology, the way you see your place in the workforce, the way you see your place in your organization, and the way you see information technology within organizations. So you're ever expanding your viewpoint, um, coming into grad school here. Undergrad is kind of about teaching you a specific skill and how to get something done using that specific skill. But you guys are not undergrads anymore. You are graduate students. And at the master's level, it requires an entirely new, you cannot learn a simple algorithm, a simple method, like, learning how to use a while loop in Java and then using, you know, uh, conditional statements and loops to solve a word problem in Java. That's not where we're at anymore. That's undergraduate level learning. What you're doing here at the graduate level is reading information, and then applying it intellectually. There's very little work. Well, there's no work in this class where you just write a program that does something, or you write a SQL query that summarizes some information. Nothing that you are doing here is easy, hands-on, mechanical like that. Everything you're doing here requires analysis of the instructions, analysis of the information that you're reading, especially Langer. Guys, Langer is what separates a new undergraduate technician from someone who is becoming a leader at the business level, a leader at the organizational level. So I hope you guys will understand that you need to make that leap, that you need to come up a level in the way you think, um, just as you have throughout your undergrad education. Um, you're stepping up, but we'll get on that more as we discuss Langer. Chapter 4, Bourgeois, talks about data and databases. Um, Read the chapter, check it out. If you have any trouble with the material, please post a question in the week 1 general questions thread. But here are the differences between, or here's the objectives of the chapter. I'll go through them briefly in over these slides, but it's all in there. Uh, now here's a framework that you will see. This DIKW model has been documented all over the internet, documented, discussed, researched. So the diagram draws from the bottom up, the bottom being the most detailed data. Data is detailed, it's raw, it's ones and zeros or numbers or words, but it's not really formatted. Data, think of data as like if you saw, you know, 1-0 Oak, Pink, Arkansas. Well, that's data. Those were data items, but they don't have any meaning. You don't know what one, what? Oak what? Is that a street? Is that a tree? It's you don't know anything when it's the data. But moving data around is important. Storing data is important. But in this model, you need to realize that data in the diagram on the right, data is the lowest level, and it's just the stuff that you use to form the higher levels. Okay, so data moves up to be information. It's information if you know that one is the the floor of the building, and oak is the color of the stain that you're going to use on the wood during this production run of furniture in your factory, and that pink is the color of the dress that you're manufacturing. So when you start assigning meaning to the data in the form of, like in a database or in a spreadsheet, you'll have column names so that you understand that that column name, last name, brings meaning when you start looking down the column and you see, uh, you know, Patel and Smith and Johnson under last name. So data is, or information is processed data so that you can kind of start to you can get some sense of meaning out of it. And you can start to, with, once you have information, you can start to look for answers to questions, and that is where you move up into knowledge. And again, this is just a framework, guys. This isn't something in concrete. It's just a model for you to think about how uh, how these terms sort of relate. Knowledge is where you could look into some information and you could maybe say, hmm, In my information store, in my database, I can see that the average age of uh, people enrolled in the Master of Science in Information Technology at the University of Cumberlands is 25 years old. Well, knowledge might be uh, looking at that average age semester by semester by semester by semester, and uh, maybe realizing that the age is increasing. So now you have knowledge of a trend in your information, and that trend in your information was derived from raw enrollment data. See how this is a building block, and then perhaps uh, wisdom kind of starts to leap beyond the information, beyond the IT, beyond your computer. And maybe I know, as a 55-year-old career IT guy and educator, I know that aging enrollment in a particular program means that your students are bringing more experience, and we need to perhaps offer different courses because they've been in the workforce longer. Perhaps we need to change the way we present the material and provide things at night because we have more working professionals. So that's where wisdom is, where you start to combine what you know and have experienced, or what the organization knows or has experienced, with the knowledge that's coming out of uh, you know the information. So we've got the word explicit and tacit here uh, injected. Explicit is something that is, it's just like when you're writing software. Explicit means it's stated. Tacit means it's kind of derived. It's something you're sort of thinking of, and you need to just work those two words into your vocabulary. So you have tacit knowledge transfer and explicit knowledge transfer. If I tell you explicitly that the door opens at 8, okay, that's great. But it's more tacit if, as an organization, we all know that maybe sometimes the door's a little early because the security guy likes to show up early. That's tacit knowledge, where you kind of have to be around a little while and figure it out. Anyway, like I said, this stuff isn't concrete. Don't go looking for level one knowledge of these things. Think about this stuff and use it in a little bit higher depth of analysis. Okay, so that's that. Now, of course, where do you go? Everybody's heard the term big data and data. And where do you go from just data to big data? Well, we'll get into that a little bit more, but in the course. But just for now, think think of data coming into an organization. It starts to be big data and big data technologies and big data analytics. There are three V's. V is in Victor: velocity, volume, and variety. And when you have large data sets that are coming at you all the time because you've got you know 10,000 people in your company or 100,000 people in your company, and you've got 2 million customers, and you've got sensors within your manufacturing floor, and security cameras, and then you've got competitor data being generated and social media data being generated. Imagine all of that data coming at you as the chief information officer. That's big data. How do you deal with it? How do you analyze it? It's an expertise area all in and of itself. But to know big data, you kind of got to start at small data, at normal data, at structured data. So make sure you're reading this chapter, and make sure you understand the basics of relational data, because that's the foundation for a lot of stuff out there. Relational data and relational database management systems and that sort of thing. Okay, so A database, don't think of a database is a store of information, a place that houses data. A database could be literally, I mean, you could get a piece of paper and start writing down things that you see. You could start on the internet, say, you could write down, week by week, your own general impression of what the top topic, the most important topic of the week was on the evening news. And you could write down a date column. You could have a column that's the date. And you could write as of the Friday of that week. So you could have a column that says, for the week ending, and then in that column you put Friday, Friday's date. And then the next week, you put Friday's date. And then you can have one other column that says the top biggest topic on the news for that week. For lately, the biggest topic of the week was coronavirus, I would say. Prior to that, it was the Democratic primary, maybe. Who knows? Prior to that, it was I can't even remember that far back. Might have been severe weather, people dying in tornadoes around the world. It could have been the California wildfires were the biggest topic of the week. So you can create a database that's something that simple. So don't think about, Oracle is a database. No, no. Oracle's a company. Uh, MySQL is a database management system. A database is just a collection of information that starts to make sense of something and collects data that you can use. Remember the previous slide, to make information. Okay, so the common defects of a database, is maybe you messed up and you gathered some redundant data. Um, maybe you write the date down in the wrong format. So if you don't have some sort of system in place, there are all kinds of problems that can creep into a database. Um, so that's where, the evolution of what you normally think of as a database is, software like Access or Oracle or MySQL or SQL Server or Ingress or Postgres or SQLite or MariaDB or any of those, So uh, here's another, that third bullet, relying on human memory to, a database could be in your head. I mean, it's really that generic, the term database, but you'll move forward and you start to organize stuff, and that's where you start getting into, no kidding, at least some sort of file base like Excel spreadsheets. But normally we think of columns and rows and tables being in some sort of relational database management system. Now here we have an example of a relational database, one single column I mean, sorry, I'm sorry, one single table. A table is really the primary building block of a relational database. Um, you have columns and rows, just like it says on this slide here. Pretty intuitive, right? Each row has to have a unique identifier. And then from there, to you can start to pull information. Once you have your data in a table like this, you can start to pull information. You can say, in the SQL language, which is the language of the data of databases, you could say select student major where student ID equals 1234. Bam, marketing. That gives you the answer to the question, what is student ID 1234's major? And the answer, marketing, pulls up. So relational database like this lets you start to gather information, and you can either use SQL to present it on a screen, or you can write a database application that puts it on the screen. Many of you are in software development, and I know this is really simple crawl, walk, run background information for you, but that's relational data. Once you have something like this, now If I have student ID, now I can go create more tables that list what classes you have taken or what classes you are enrolled in. And that relates back to this, but I don't have to store your name over in that. All I have to store is student ID. I can come in and get the name of everyone enrolled in ITS631 from the student table. I don't have to store that name in every other table that talks about you. See, that's the beauty of relational. And there's a section on normalization in the text. Holler if you need help with that. But as an IT pro of any type, it doesn't matter what if you're cybersecurity or blockchain or what you're going into, or if you're a programmer, you need to know normalization. You need to know what normalized relational data is because it's everywhere. You cannot get away from that in IT. So please make sure you understand those fundamentals. And here we link up tables using primary keys. Remember, a foreign key is just the key in a previous table. So moving from left to right, you got student ID as the primary key in the student table, but then student ID is a foreign key in the grade table. So those aren't, that's not rocket science. And that's how you link information back. But again, we can find out, who's sitting in the classroom by linking classroom ID back to course, back through the grade to the student ID. So we don't need to store the name of everyone sitting in the classroom. We link it back through these table linkages. Um, so if you're not familiar with this, you're not going to learn it in in 10 minutes in week 2 of ITS 631. If you want to learn more, make it a course of study for your own personal development program. But that's how relational data links back. Um, and again, we talked about normalization. It makes it so that you don't have to store. It reduces redundancy, so you don't have to store things like name over where alongside the courses that you're taking. You When normalization makes sure that you only store data in one place, but it can be related to other items when you need it, and it ensures integrity. One way it does that is referential integrity, where if you have a database management system in place, it shouldn't let you delete. Like I shouldn't be able to delete you as a student without deleting all the courses that you've taken. And of course, no university would delete you. We always keep everything forever. But as from a database standpoint, it's called orphaning records. You wouldn't want to delete the parent of some subsequent records so that they get orphaned in the table and left sitting there taking up space with no parent record to ever utilize them or link back to them. So that's a database function. And then of course, if you're in software at all, you know all about these data types. Um, a text or maybe a string might be something that you'd see. Um, of course, we have different types of number data, Booleans, yes or no. Date time is usually its own kind. Currency is a special type of numeric data. But you'll often have paragraph text or an object. You're seeing that a lot more, where databases are handling a large, whether it's an XML file or an image. You're seeing where databases will handle large binary objects. Sometimes, like in SharePoint, I think they refer to it as a binary large object or a blob. You got a blob of data. That's very unstructured. It's whatever's in that large object is a little bit difficult to utilize. So, but you've got it stuck in your database. Anyway, we'll move on. Now, a database management system is a software package that lets you work with a database. Okay, Oracle installed on a server in my network at work is a database management system. Oracle is a company. if I install version whatever 11, um, now I have an RDBMS running that I can use. So that's kind of the difference between the systems. Um, Now, the second bullet, most relational databases, you can do a single user database, but really their beauty is in multiple users updating records concurrently, which makes them more complex and harder to manage. But uh, personal database, you've got Apache OpenOffice and Microsoft Office, Microsoft Access. Those are more really intended to be single user database management systems, but they do the same functions. They'll keep you from, if they're developed properly, they'll keep you from storing redundant data. They'll keep you from orphaning records. They'll throw up an error if you try and put in the wrong data validation. There's a lot of things that an RDBMS does for you. Uh, and then the fourth bullet, they provide structured query language, which guys, this is almost like written spoken English. It's almost like asking a question of the computer. If you don't know SQL, I like there's a little program out there called DB Browser for SQL Lite, SQL Lite, LITE, and there are sample databases for SQL Lite. There's one at the end of this chapter for baseball statistics. I downloaded it. I haven't used it yet. But I've got a program called DB Browser that lets you pull up a database and look at it. Um, you, I encourage you to learn SQL. Okay. Um, there's almost nowhere in the IT world that you won't use it. So if you don't know it, learn it. If you do know it, great. I'm I'm preaching at the choir, as we say. So that's what a database management system is. So it's sort of an evolution, of a database to implementing it in a database management system, and then the database management system itself. So the value now we're moving up a whole level. Now you've got lots of structured data all lined out in there in an ERP or that you've collected from somewhere out on the internet, but it's all clean and structured, and you can do data visualization now. A friend of mine's a Tableau expert. He was showing me some things that you can do, but even like drawing a histogram or a pie chart, those are visualizations that bring new meaning to you as a human being out of the data. They provide information more than the raw data. I mean, you know how it is when you pull up a spreadsheet or you select star from a table. It just looks like a bunch of running numbers and words. You can't really get any information out of that. But if you pull that data into a chart, it can often which is a visualization. It can often instantly make it much more meaningful to you. A data warehouse is classically pulling data out of your operational systems and putting it in an offline place where you can do analysis. That's you don't generally you don't want to be doing analysis queries and mucking around with data in your live production system, whether it's HR or manufacturing support or supply chain. You generally don't want to do trend analysis and reporting and all of that on live data. I mean, you can, but certainly you don't want to be doing large scale historical studies and whatnot. You want to create a data warehouse, and that lets you go back and do statistical analysis. Data mining and machine learning is, of course, just going through the data using particular algorithms, asking questions. It's almost like mining uh, for diamonds in the sand in Africa. You don't know what you have, so you go through looking for things. Sometimes you find something really significant, like the miner finds a diamond in the sand. You might find some new business insight or some trend or some problem or occurrence. Data analysts do this all the time. They deep dive into the data looking for new uh, new information. And of course, machine learning is an emerging trend for getting your computer software to learn from the data and spit out new insights. And of course, with data, everybody's worried about their data being used, whether it's Google data or Facebook selling your data. So that's a whole nother world to talk about. And knowledge management. Knowledge management takes the information and starts to put it. You'll see a lot of dashboards. Some of you may be in this line of work where you start to pull real-time information, and this is the opposite of a data warehouse. A KM dashboard, a knowledge management program, usually extracts information to provide useful data right now. Like, it could be, I've seen pretty good applications of KM, like in a restaurant, when you get a rush. It lets the restaurant manager know that the rush is over and we can start uh, letting people go home, letting people clock out. It could be that a manager at Walmart gets an alert that the lines are getting too long, um, and we need to open more registers. It could be a KM dashboard at a manufacturing facility that says we're running low on a particular raw material, or the toner in a cartridge is getting low for some part of the process, or a 3D printer is getting low, and whatever the case may be. A KM dashboard is a way to pull data and make sense out of it. Almost, you could almost think of the dashboard of your car as a knowledge management system for operating the vehicle, whether it's the moving map from your navigation system, the speed of the car, how much fuel you currently have in the tank, how many miles you've gone this trip, and whether or not maybe it's time to pull over and stretch your legs, what channel is on the radio. There's all kinds of information, all kinds of knowledge that is being pulled from the car and assembled for you. There's all kinds of information that's being assembled into knowledge as to how the car is operating. I guess that'd be a metaphor. So that's what they use. They use KM dashboards as a metaphor for actionable knowledge that's being used to inform the decisions of your leadership. Okay. Now we get into Langer. Okay. This is where, no kidding, you guys, no kidding, are becoming graduate students and starting to address um, some graduate level learning. Um, Technology is a variable. What Langer goes into in this chapter is that technology changes. Okay. Some organizations are responsible for that change, but no one organization is responsible for all change. I would say, there are certain key players that have been responsible for massive changes in technology recently, like Amazon and cloud services, like Apple and the iPhone. It's been 13 years now. You guys don't probably you may remember the iPhone coming out. Um, and if you do, yeah, I mean, you guys are probably what, in middle school, right? When the iPhone came out, and you could suddenly, look up anything walking down the road. You had the sum total of man's experience now in your pocket. You didn't have to go to a computer and look things up anymore, and it changed everything. You can do almost anything from your mobile phone. So the iPhone was one of those technological changes. But there's other, I mean, think about it, when the automobile came around, what shift happened in our societies and in the cultures of organizations and in the culture of society when the automobile was developed, or the airplane, or the locomotive, or name it, or the computer, the personal computer. All of these things are technological changes, and now we're seeing things like drones. What is that change? And there's a lot of people that a lot of things we used to be ignorant about that we can now get a picture of. Um, drones are doing delivery, so there are going to be apparently, drivers being put out of work, or they're going to have to shift what they do. So think about technological change as a variable, almost like it's being injected into the model of your normal organ businesses, kind of like an organism, right? And technological change is like an illness, like a virus that happens and then gets injected into that person. And whoa, what's the impact? What's the effect? Well, it's dynamism, and which is just dynamism is just like something is dynamic. Dynamic is an adjective. Dynamism is the noun form of the word. It's just change. It's just causing it's turbulence. It's change. Um, and responsive organizational dynamism is just how an organization responds to it. Some organizations respond to that dynamism well, some don't. But Langer is encouraging organizations to respond well. Um, and This chapter focuses on the components of technology and how they affect corporate organizations, and moving IT around. Remember, Langer's all about the culture of IT within an organization. You need to make sure you've got this text, because you're flying in the dark if you don't. Because he goes into this Ravel Corporation, which is a pseudonym, so that it protects the protects the innocent. It's a corporation he went into where he learned a lot about culture and the role of IT and a lot of things like that, and he uses it throughout the text. Um, uh, so this chapter tries to address how organizations adjust to technology. They just use the word technology, but it's information technology is what we're focusing on, to its short and long term impacts. Short term, it disrupts. Long term, it has a positive impact, and there's a lot of change in between, as we discussed last week. Resistance to change, and uh, and and an organization that does responsive organizational handles organizational dynamism and technological dynamism well, is going to come out on top. So that's the crux of the chapter. Make sure you read it. I had to browse it pretty heavily this week, so that I get it. And also, you need to understand that Langer is giving credit to other authors. Okay. So look at the way Langer refers to other authors, frameworks and pillars of, uh, and and you need to learn how to write and credit other authors in a similar fashion. As you move forward in your education, you move up into the PhD level, that becomes particularly important. So, like I said, here's technological dynamism. It's on the first few pages. Stuff changes, guys. Technology comes out. There are companies all over the world thinking of new cool ways to make money, and how to put the pure research that's being done in laboratories and monetize those advances. And stuff happens, man. Technology comes out, whether it's new materials, new information technologies, new programming languages, new devices, new approaches uh, to the way things are done, like agile. Could be thought of as a technological change, but it's just a procedure. It's just a way of doing business. Um, so but it causes motion. Now that motion can be controlled, or it can be uncontrolled. It can be chaos. So that's what Langer goes into in this chapter. But it's unpredictable, but you can be ready for that unpredictability. You can have people in your organization that are paying attention as close as possible to what's going on out there in the laboratories, what people are working on, so that you can kind of sort of try to predict what might be the next big thing, and what might impact the way your organization is working, and what technology may threaten you and what technology may enhance your organization. So it has to go into that'll change the way you do strategic planning, and chart the course for your organization. You all may not be thinking about things in this frame of reference, but you need to start thinking that way because that's where you're headed as graduate students. And then you got this responsive organizational dynamism. That's where technology comes in, and there's two primary ways that technology is dealt with. So you have technology comes in and causes dynamism, right? This technology comes in and causes change. It causes turbulence. Okay, now there's as an output of that, your organization is going to react. Okay, it's almost like like I said, the rhinovirus, the cold comes into the organism, and symptoms of that of that rhinovirus come out, runny nose and fever. And now, what do you do about it? Maybe you do nothing, and you just suffer through that cold for longer. Maybe you take some vitamin C or some airborne or some other. There's actually treatments now for rhinovirus. So maybe you have a method of dealing with it. Maybe you don't. Just like organizations either have or don't have a method for dealing with technological change and organizational dynamism. So there's like this change causes an acceleration of events. You have to deal with it. You have to do something with it, and it usually it can relate to actually changing the organizational structure. You got to remember, guys, this is big picture strategic thinking here. This isn't anything easy that you'll get your brains around immediately, but it requires strategic integration where you look at the change and how we're going to deal with it, and then a cultural assimilation, which is, as we discussed previously, where you get over the resistance to change and you start to it becomes the new norm. But there's another level of this model that Langer goes into, that you need to understand. Uh, uh, Cultural assimilation is where something becomes normal, at part of the culture. It could be like you'll see in your assignments this week. Uh, BYOD could be something you would discuss. Bring your own device. Older people in the organization maybe hate your smartphone. Younger people in the organization can't live without it. And then you've got, how do you support BYOD within the IT organization? So it could be cloud computing. Some people may be nope, you know, we're not storing our data in the cloud because I don't have control. Other people maybe assimilate that technology faster because they realize the benefits. Um, and then the movement of traditional IT staff, is it distributed? Um, Langer Langer makes a good point in chapter 3. You as an IT professional are not the only person in your organization that knows IT. All this information is out there. A good educated person, regardless of their functional area, should know the basics of IT and how IT affects their line of work. And often they're ahead of you in that line, in that regard. So be careful. But anyway, make sure you're reading this chapter on, and he's got a section on cultural assimilation and how organizations, the people, adapt organizationally, and culturally. And um, then we've got the business cycle here. Is this technology feasible? Then we measure its use, and whether or not it's worth even dealing with. And then we do project plans for implementing. We implement it, and then the evolution. We evolve. We look back at how it worked, how it didn't work, and the evolution of that technology within a company. Like now, mobile computing used to be, ooh, the new guy got an iPhone, wow, or maybe only the leadership had a BlackBerry and they were special because they had a BlackBerry computer and they could check their email from that computer. Again, this is, we're going back 15 years or so. But there's an evolution of this technology where it goes from something weird to being something normal, to being assimilated into, to being something that you have to now support, to being something that maybe we can even just get rid of and consume it from outside. And that's the cycle that Langer's going into. See this. Make sure you understand the difference between a driver um, and supporters, drivers and supporters. A driver is something that's the core of your business. A supporter is something that makes that happen. And generally, a driver is something that you have inside of your organization and you care and feed it. But then it becomes kind of something. Uh, it almost evolves into being a support thing that you now outsource, which you could think of as um, uh, like IT. It used to be a driver of heart and soul of a business, and now maybe it's something that we can just kind of pick off the shelf. We don't have to develop our own applications anymore. We can just subscribe to software as a service. And then there's this, this loop. But again, this is thinking technologically at a strategic level and organizationally at a strategic level. This isn't like, you know, installing the latest version of uh, Windows on your PCs. That's not what we're talking about here. This is the larger scale um, technological change. So make sure you're thinking strategically when you address Langer. There's very little in that book that is undergrad level, um, where you can just memorize facts and spit them back out. We're getting past that now here, guys. So here's your assignment for the week. We've got a 5-point discussion, um, and then I ask you for examples. So by Thursday, you should have read Langer a time or two, and then post your discussion. And again, guys, remember, I like discussion posts that are conversational. I do not expect you to lecture as if you're an expert on this. I want you to make it personal. So I want you to say things like, "In my experience," and "What I have found is." Make your discussions uh, uh, personal, professional, of course, professional language, but make them personal to your experience. Don't just share stuff that you found on the internet or read in the book and you've rephrased, okay? Bring your thoughts and experience and opinions into the discussion so that we can talk. We can literally, like we're standing around in the break room on Friday afternoon at work, and we're talking about work. That's the way I want these discussions to flow. And then, of course, you've got um, some exercise questions and exercises from Bourgeois. Put that all in one document. Um, and then, uh, if you're listening to this lecture, please don't tell anybody else. But on exercise 5 of Bourgeois chapter 4, only turn in one page. Everybody else is going to read that and they're going to see 2 pages are due. But if you can answer that in a page or even a little less, um, uh, you're welcome to. So, but I'm not, like I said, I'm not gonna modify that in writing anywhere. I'm gonna see who listens to the lectures all the way to the end and waits for what they call it, an Easter egg, right? There you go. There's an Easter egg in my lecture. And then Langer chapter 3. Now this stuff, guy, this is requiring you to think and analyze and really know what you're talking about. This is not something you're going to be able to guess your way through or find some stuff on the internet and kind of put it out there in a paper. This is a couple page APA format paper where, no kidding, you're um, you're 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 analyzing what you've read and telling me letting me know that you get it. Okay. Um, there's a couple things to note there. A couple of sections that should be in your paper. If you need help with that, shoot me an email. Um, but this level of instructions are what you get at the graduate level. It's not, you know, little tiny bite-sized chunks that you can just knock out, yes, no, taking a little quiz. Um, this Langer Chapter 3 assignment for 15 points um, is graduate level work. Okay, so again, if you're having trouble, shoot me an email. Let me know what you need help with, but be specific and don't do it from your phone. Don't send me an email tapped out from your phone. Okay, be very clear. Take your time. Use a computer, and let me know what I can do for you. Same goes with questions in the classroom. Every once in a while, I'll get just a nonsensical, and this is from PhD level students. I'll just get a nonsensical one line uh, question in my email sent from my iPhone in my email and or in the classroom area. I need you to be thorough. I need you to give me the background of what's causing you trouble, and then ask your questions, um, and so that I have a shot of answering it without going back and forth and back and forth and back and forth. Okay. All right, guys. I look forward to a productive week 2.